As you write your research methodology, there is going to be a point where you need to describe who is going to be your study participant. In other words, we call this person a study respondent. So this person is derived from what we call a study population, and we are going to derive what we call a sample and sample size. My name is Alan from Professional Writers, where we specialize in writing all kinds of professional documents, including research proposals, dissertations, theses, project proposals, and all other kinds of professional documents. In today's class, we are going to be looking at how we do the study population section in your academic research, how we do the sampling in your academic research, and how probably are you going to defend these things when you go out for your proposal defense. So you could be a student who is undertaking your study. You could be someone who just wants to learn about research. We got all of you covered. So this part is always in the methodology section of your thesis or your dissertation. And we are going to be exploring the right ways of doing the study population. I have done this today because this is one of the sections that gives students a little bit of hard time. And it is one of the sections that professors and other people at the panel are going to be focusing on to confuse you and make you look like the study is not yours. So let's go through this slowly and we can understand how to write a better study population and sampling in your academic research. We'll start with the basics. What is a study population? So a study population is a group of individuals who are selected on the basis of the inclusion and exclusion criteria. Okay? So what is the inclusion and exclusion criteria? Now, every time you're going to do a research, you're going to think of who you want to involve in your study. And this person is called a study participant, or in other words, a study respondent. Okay? So the study respondent is going to come from a study population. This is a group. It could be a group of people from which you are going to conduct your study. So, for instance, with the topic that we have been that we looked at in the previous lesson of the effect of employee motivation on their performance, we wanted to understand the effect of employee motivation. If you motivate your employees, are they going to perform better or not? So in that case, you would say that your study population is going to be the employees, if you just look at the topic. So among the employees, we are saying that we are going to do an inclusion and exclusion criteria. So an inclusion and exclusion criteria, we are saying that among these employees, who are we specifically going to include in our study? And who is that person that we're not going to include in the study? So as much as we have said that our study population is going to be the employees, at this point of the population, we need to exclude some people. For instance, it is very difficult for you to go to a company and find that all the employees are present. Maybe some people work the night shift. Maybe some people are on study leave. Maybe some people are on annual leave. Maybe some people are sick. Okay? So it is very difficult for you to include those ones. So those ones are not going to be a part of your sample. So even when you're doing the sampling, those ones are not going to be a part of the population because you're going to exclude them from that level. So in other words, when you're asked, what is your study population? The answer that you give is not a number. The answer that you give is a type of individuals. A study population can be people. In this example that I gave, it could be employees. Those are people, human beings. You could have employees as a study population. You could have students in a school as a study population. You could have any kind, maybe nurses in a hospital, as long as you specify a specific group of people. However, it's not always that a study population is represented by people. A study population can be represented by rats, for example, if you're going to study rats. So your population is going to be the rats. and then maybe you're doing an interventional study and you want to understand the effect of a certain drug on the rat, so that population is the rat. In some cases, when you are doing secondary data and you're going to collect data from secondary sources, even your patient, if you're doing maybe from patients, the patient files could be the population. So what is the population? The population is the source from which you're going to get answers of your data collection tool. So whoever you're subjecting the data collection tool to, or whatever you're going to use to collect, whatever you're going to use as a medium to answer the questions that you have put in your data collection tool is going to be called your study population. Okay, I think that makes some sense. So let's take a look at some other things. There's what we call a study sample. So what is a sample? A sample is a subset of individuals, items, or data that are selected from a larger population. So sampling means that to get a sample, we need to get a small representation from the entire group that we had earlier on. So it could be individuals, could be items, could be data that is coming from the bigger group that's a sample. So sampling, as we can see here, is the process of selecting a subset of individuals, items, or data from a larger population. And that is the focus of today's lecture, how we do that. So we are going to ask ourselves, we have a big population. Maybe you go to a company and the company has 10,000 employees. How are you going to select the employees which you're going to involve in your study? So the question is, are you going to involve everybody in your study? No. So if you're not going to involve everybody in your study, how are you going to select those few people that you're going to involve in your study? That is what we are going to be looking at today. The other thing I wanted us to know is what we call a sample frame. So a sample frame is a list or database that includes all members of the population. So you could go to a company and then they will tell you that in this company, we have the employees. So, but the employees work in different departments. Maybe we have employees that work in manufacturing, we have the employees that work in HR, we have the employees that work in IT, we have the employees that work in marketing. So for you, you'll get a good sample frame to know what employees that you're going to involve in your study. And then the other thing that we want to know about is what we call the sample size. This refers to the number of individuals or items that are included in a sample from the population of the research study. So many people confuse sample size and population or the sample. So the sample size is just that number of people. We also have what we call a population size. That is the number of the entire population. But the sample size is the number of the smaller sample that you have chosen. Okay. So when you look critically at this graph, you can see that sampling methods are so many. But for me, I have chosen a few sampling methods that are commonly used in academic research. So majorly, you will see that sampling can take two ways. It can be a probability sampling or it can be a non-probability sampling. So as you can see that probability deals with chance, and this, you're going to create a way in which it is only chance that can help you attain the kind of respondents that you want. However, non-probability sampling does not use chance, and you are going to use another way that is not by chance to get a respondent. Let's take a look at some of these methodologies that we use to calculate, to do sampling. First of all, let's look at probability sampling. So in probability sampling, we have so many ways of doing probability sampling. And I'm going to take a look at them here. So the first one is what we call the simple random sampling. And if you look critically, what is the simple random sampling? So simple random sampling is when each member of the population has an equal chance of being selected to be included in the study. For instance, if we take a look at the example that I just gave earlier, the impact of employee motivation on performance. Okay? So when you look at that, you'll see that for us to involve everybody using simple random sampling, we need to devise a mechanism in which everybody is going to feel like they were chosen for the study. So one thing you can do, maybe you could go and call up all the employees of the company, put them in a hall, maybe the company hall or at the compound, and then you can say, okay, I'm going to write papers. If, for example, there are 100 employees, just an example, you could say, I am going to write 100 papers, small pieces of paper with numbers written inside and then folded. Okay? So when you write those, you write and fold them and put them in maybe a basket or a basin where they can be random and someone can easily pick. So depending on the sample size that you want, maybe if you want a sample size of 50 out of 100, you could say everybody who has picked from number 1 to number 50, if you see that you open up the piece of paper and it is written inside 1 up to 50, you're going to get involved in this study. But if you have higher than that, you're not going to get involved in the study. So this one makes sure that people don't feel like you left them out intentionally. So that is simple random sampling. So the way you do that can vary depending on, you can use a software, you could even use a software, you get all the identities of the respondents, and then you can run a software and then it can give you the sample that you are going to include. Okay? Yeah. So now, the other way of doing probability sampling is what we call stratified sampling. So stratified sampling is when we divide the respondents into distinct subgroups that they might belong to. So for instance, if we have a company which has 5 departments, one way of doing simple random sampling would call all of the employees together and then we sample them at once. The problem with that is that that chance might put you on only people in the same department. You'll see that you might have collected people from a single department. And yet, if you're studying, you want to understand perspectives of people from all the different departments. So that's why we stratify. So stratify, we could say, we're going to put people in different groups. We are going to put people who are coming from marketing in one group, people who are coming from IT in another group, people who are coming from administration in another group. And then we are going to be sampling from each of those using random sampling, such that we get an equal representation from each of the stratas. So that's what we call stratified sampling. And then we have what we call cluster sampling. So in cluster sampling, we distribute the clusters depending on the geographical location of the study units. So you could have a company and you're studying the impact of employee motivation on performance of the employees. But maybe the company has 5 branches in different parts of the country. And maybe you want to understand what is going to happen to employees who are located in the eastern part of the country. Maybe they face a different set of challenges from those that are located in the central part of the country. So we need to cluster and say, okay, I'm going to first cluster people and sample them depending on where they come from, maybe the branch of the company where they work. So that's cluster sampling. And then we have systematic sampling. So systematic sampling is when you sample every nth or the kth number of population. For instance, if you put 100 people in line and you say that I need you people to count, maybe you count 1, 2, 3, 1, 2, 3, 1, 2, 3. So every time you're the third person, you're going to get involved in the study. So that is the systematic. So you count 1, 2, 3, and every third person gets involved in the study like that. So now this is probability sampling. And if you're having an academic research where you have a bigger number of people in your as your participants, you're going to choose one of these ways of sampling, because these are some of the ways in which we sample a bigger what? A bigger population. That is probability. However, there could be cases when we don't need to do that, when we need to do non-probability sampling. So non-probability sampling means that you're not going to base on chance to get the respondents. So we have so many examples of that. So the first one is called what we call passive sampling. So per passive sampling, participants are chosen based on your researcher's judgment about who will provide the most relevant information. And this is mostly important, especially when you're choosing from a smaller group of people. Maybe you want to understand the issues that are affecting employee motivation on the side of the administration. So you will find that maybe administration has 10 executives and you want to sample from those. And you will ask yourself, who is the best person that knows more about employee issues? Maybe it could be a human resource manager. So you're using your judgment as a researcher to think of the best individual or person who's going to answer your research questions better. That is passive. We also have what we call convenience sampling. So convenience sampling, this is when participants are selected based on their availability. As I told you earlier, you might go to the company. Some people are off duty. Some people are sick. They're on sick leave. Other people traveled. Other people are on education leave. Okay. So those people who are available are the ones that you are going to go ahead and sample. Okay. And then the other sampling method that is commonly used in academic research is what we call snowball sampling. So this exists when study participants are the ones that are referring you, the researcher, to the next study participant. Take an example of a study. Maybe you think that there is a lot of crime in your community, and then you know only one of the criminals in the community. But we also know very well that criminals know themselves. But if you want to study 50 or 30 criminals, it is very difficult for you to find them gathered somewhere. But if you know one and you talk to them, explain to them the significance of the study and convince them very well, there is a very high chance that that one is going to refer you to the next criminal. And then you can also collect data from that one. So they keep referring themselves like that. And it is also put in studies with sensitive phenomena, things like prostitution. Okay. Prostitutes know each other. So if you interview one prostitute, they are likely going to tell you who the other prostitute is. So if you have a study like that, you can continue. So as a researcher, you have to choose a sampling method with a reason, a backing of the reason as to why you have chosen it. If you've chosen simple random sampling, you have to have a reason as to why you've chosen that one. And if you have chosen non-probability sampling, like these ones, you also have to have a reason for it, because this is what you're going to be defending in the panel. Okay. So I think we can also take a simple look at why it is important to do sampling. So sampling can be really very important in many ways. The first way is it helps for us to save. It is cost effective, because it is very difficult for you as a student to go and do a study and involve everybody. So if you involve a smaller group of people, it is going to be cost effective. It is time efficient, since most of the time students are only at school or at the university for a specific period of time. So you can choose the sample and only review those for that specific period of time. Feasibility, it is also possible to do when it is on a smaller grid. It is also efficient because it helps to enhance the efficiency of the research process by streamlining the data collection and analysis, leading to quicker and more effective results. Okay, so now we want to talk about sample size determination. And this is what is going to differentiate you from a quack researcher. And if you understand this part, there is no defense panel that you're not going to pass. So sample size determination is the process of deciding the number of observations or participants to include in a sample for your study. So in other words, this is the formula that we are going to use to get the sample size. So now, there are things that affect your sample size that I want us to look at. The first and foremost factor that affects your sample size is what we call the population size. So the population size is going to be, if the population size is big, there is a very high chance that if you're going to do a good study, then you're going to need a big sample. For instance, if you go to a big company which has 10,000 employees, you cannot sample 100 because 100 cannot represent in any way what 10,000 employees think. So as much as you'd want to achieve the advantages of sampling, the population size is going to influence the sample size. So the bigger the population size, the bigger the sample size. But there is a certain point at which increasing the sample size does not help us. So at that point, we only get a specific sample that rhymes even with a bigger population, as we shall see in a few minutes ahead. So another factor that is going to influence your sample size is what we call the desired confidence level. And this is called a desired confidence level. So a confidence level, what is a confidence level? And I see people saying these terms, but most people don't have an understanding of what this means. And if your professor knows that you don't have the understanding of what these things mean, they are going to ask you these questions to start confusing you, and they'll end up saying that this is not your research. You need to go ahead and change the topic, which is not a good thing. So the desired confidence level. A confidence level is the statistical measure that indicates how you, the researcher, are confident that the results that you are going to get are not due to chance. So a confidence level. Let's start with a smaller example. Let's say the company that we are going to do our assessment, the company in which we are studying motivation and performance of employees, has 10,000 employees. Let's say that we pick a sample of 1,000 out of 10,000, and then we do our study. Are we going to get a certain result? And the answer is yes. What if we go ahead and pick another sample of 1,000 and we subject them to the same data collection tool? Are we going to get the same result? Yes. If we do that again and again and again, so if we do that 100 times, okay, how many of those 100 times is it going to be that we are going to get the same exact result from all those 100 times? So if I think that out of 100 times, 95 of those times we want to get the same exact result, I am going to put my desired confidence level at 95%. So that means I'll be confident 95 times out of 100 that even if we sample again and again and again, we are going to get the same result. So it is important for you as a researcher to understand what your desired desired confidence level is. So if you're doing as a normal study, like in academic research, you can have a confidence level of around 90 to 95. But if you're doing a study maybe an interventional study, maybe in medicine, you need a confidence level of around 99%. So you should know that the higher the confidence level, the higher the population size. Okay, so because you need a bigger population for you to achieve all those things. Okay, these things will make sense as we go. And then we are going to talk about something that is very commonly said by so many people, and this is what we call the margin of error. So what exactly is the margin of error? And I hear so many people saying that word, margin of error. So the margin of error is the percentage that measures the degree of uncertainty in survey results. Okay, so let me try to simplify this. So every time you go and pick a sample from the population, you already have made an error, because even if the population has 100 respondents and you pick 99, there is a very high chance that maybe the one person that you left out is the one that has and the information that is going to deviate the results. So there is that error already. So we want to calculate the margin of error that is in the sample as regards to the entire population. So you'll see that a smaller margin of error requires a larger sample size in order to increase the precision and reduce the range within which true population parameter is expected to fall. So let's say that you have a population of, say, 100 employees in a company, and then you're going to go and pick out a few of those for your sample. We want to calculate, if we did this study, what is the probability or the chance that what the respondents are telling us is going to be the exact thing that the entire population is going to tell us, in case we had done a study, in case we had done a census, or in case we had included everyone. So that is the margin. So you will see that a margin is always included by a plus or minus, and then they put a number. So it's a plus, or it could be a plus or minus 3, for example, which means that if we had asked people, like, if we give you a weekly allowance, would your performance increase? Okay, or would your performance improve? So if 50% of the people said that, and our margin of error is 3%, then we would have, a positive or negative margin of error. So from 50, from 40, we'll go a little bit down to 47, and maybe a little bit up to around 53. Okay. And then we have what we call the confidence interval. And what is confidence interval? So we will see that, just a sec, the confidence interval is a range of values derived from the sample data that is used to estimate a population parameter. So as you see up, we had a margin of error. So we want to get a range of values that is going to help us to represent an estimate of the population parameter. So we are going to say that if we have a margin of error of plus or minus 3, that means that in our entire population, let's say we have calculated the mean of the entire sample. Maybe if we have employees and we are calculating their age, okay, maybe we have people who are in their 20s to people who are in their 50s. So when we add and subtract and divide by the number of people, we shall get a mean. So that is what we are calling a parameter. So we want to understand, how is that related to the entire population? So we can plus or minus the margin of error to get the confidence interval. And then population variability refers to the extent to which the value of human population differ from each other. So this is very important, because the spread or the dispersion of the data points in the population are going to result into the need for us to have either a bigger sample or a smaller sample. So a greater variability within the population is going to necessitate a larger sample. And then lastly, the standard error is a measure of the variability of a sample statistic, maybe like the sample mean, okay? So the smaller the standard error, the larger the population size. Now, I want us to look at a few sample size calculation formula that are very commonly used. The first one is called the Krejci and Morgan table. So this is the table that is already existent. You have the population size and the corresponding sample. So for instance, if you have a population size of 50, the sample is going to be 44, 65, 56, 85, 70. It's already calculated for you. But there is a formula that you can also use, but this is so straightforward. The problem is that it assumes a standard confidence level and margin of error. So if your study has no problem with that, you can always use the Krejci and Morgan tables. The other very common formula is what we call the Tarrer-Yameen formula. And this Tarrer-Yameen formula is also very commonly used in academic research. You'll see that we have n out of 1 plus n times e squared. So we shall see that the small n is the sample size here, n is the population size, and e is the margin of error, and this is the desired margin of error. So if you're saying that you want a margin of error of maybe positive or negative 3, you're going to put it here and square it, and then you multiply it by the entire population. So this is a very common formula, and it helps a lot of students because it is straightforward. The other very common one is what we call the Christian and Leslie formula, and it is applied in specialized research contexts where detailed adjustments for population characteristics are needed. You see that for which it has so many parameters. If you look at n, this is the sample size. The z is the z-score of the desired confidence level. So if you chose a confidence level of 95%, you're going to look up the z-score of that confidence level, and you're going to put it here and square it. And then you have the p, which is the assumed population prevalence. And assumed population prevalence is obtained from various studies that are similar to the study that you are doing. So if, for instance, you're studying health workers, and you're studying maybe a prevalence that affects health workers, if there is a similar study that has the prevalence of that population in a different place, you could use that and put it here as the assumed population prevalence. And we can have also the complement, which is 1 minus p, still with our margin of error, and we can put it there. And there are so many other formulas that you can look up and use depending on the requirements of your study. Okay, so how do you choose the formula? You should understand your research needs. You should assess the population size, because the bigger population size, you can use like Krejci and Morgan tables, which are very straightforward. You can also, you need to consider your confidence level and then the margin of error. And then you also need to review the limitations of each of the formulas that you have chosen to use. So each of those formulas have a weakness and a strength. So you have to review, and then you can see which one you can use. I want us to look a little bit about the common challenges that are involved in sampling. One is what we call the non-response bias. So you should be very aware that not everybody that you're going to sample is going to actually give you results of your study. You can do your sampling so well, and then you have your sample, you even tell people that you have been chosen to be in this study. The next thing you hear is that the person is no longer available. Maybe they have got a problem, maybe they are sick, or they are not there. So that is non-response. Or sometimes you can even give them your data collection tool, and they just refuse to fill it to the to the level at which you want it to be filled, because people have different problems at different times. So that is what we call the non-response bias. And the supervisor can easily mess with you when they're asking you about these biases, and so you should know what they mean. We also have what we call a sampling bias, which occurs when certain members of the population have higher or lower chances of being selected. Especially when you're using non-random sampling, there is a very high chance that you're going to have sampling bias. And this is going to come from you, the researcher, because you're going to just passively choose someone. There's what we call sample attrition, which is normally among interventional studies that require you to go and meet the respondent again. So you might go back to the company, the person was fired. They are no longer there they are no longer there at the company. Maybe the person doesn't work the day shift, or so some factors that lead to the narrowing of the sample, especially when you have already interviewed them and you have to interview them again. Okay, I want to thank you so much for taking time to listen and be a part of these capacity building sessions. I am so happy. And I still call upon you for those ones who are interested in the premium one-on-one training. We still have that, and we can take you through how to write your academic research from topic selection until you finalize with your proposal, until you go to data analysis and discussion and the entire thesis. If you're interested in that, you can go ahead and send me a DM on WhatsApp, and then we can see how to put you in the program. So since Zoom does not give us a lot of time, I am going to beg that we put our comments, our questions, our concerns in the group, and then we discuss them from there, and then we can continue with learning from each other and improving ourselves. Thank you so much. Have a good evening.